Misconfigured Kubernetes can lead to security breaches, but it also causes outages and performance degradation. Kubernetes has many pieces and is highly extensible, which also provides many configuration options. The default configuration is not the best in most cases. It is important to know your use case and the best configuration accordingly. Let's walk you through the 5 most common configuration mistakes that may sound simple but impact production. First, forwarding all Ingress traffic to a single container. Kubernetes Ingress is an API object that provides routing rules to manage access to the servers in the Kubernetes cluster. It offers a single entry point for the cluster, allowing administrators to manage the applications easily and diagnose any routing issues. If you forward the entire traffic of the cluster to one single container, eventually the load will take the whole container down. So, the lesson learned here is to prevent the user from specifying the host as *. When configuring Ingress rules, you should instead leverage the load balancing capabilities of Kubernetes to ensure high application availability. Second, the YAML structure is invalid. YAML is a serialization language that contains syntax that can be read by humans. Indentation of white space is a complex process when managing large configuration changes. Accidental tab indentation in itself will not result in an error, but it adds up to the serialization of code. This results in the code being complex to debug and inspect, as most of the scanning tools only point out errors in code logic. To create valid YAML configuration files, you will need to heavily rely on specialized plugins and the text editor. Third, setting ImagePullPolicy to always. Always check what your ImagePullPolicy is set to, as if by default it is set to always. Every time a pod is started, it will always fetch its image from the registry, even if it is already present locally. This will cause overconsumption of NAT IPs. Effectively, the bad code will cause a crash loop which will create a DDoS attack from a NAT address on their image registry provider. If you set the pod policy to allow privilege escalation to true, it will enable the child process of a container to eventually obtain more privileges than its parent process. With this, commands that are run can override the existing permissions. In short, you will not be able to enforce the principle of least privilege for the users of a service, allowing users and applications unlimited access to resources, which will result in a single entity obtaining elevated, non-administrative access, making shared resources and services unavailable for others. The Kubernetes ecosystem relies on multiple third-party integrations to handle functions such as monitoring, compliance, and security. The Kubernetes ecosystem relies on multiple third-party integrations. Most of the time, these integrations run using operators, which are Kubernetes native agents deployed within containers of a cluster. Integration that is resource-intensive has the potential to consume substantial resources of a cluster infrastructure, as sometimes these operators are deployed as downloaded without inspecting the resource limits. Managed Kubernetes is available on the E2E Cloud. Click on the link in the description to request a free trial.